Hey, welcome back again to the third part in this series. So I went running around and I was looking for a cylinder and I couldn't find one anywhere. But lo and behold, I did find one. Now can you imagine? This cylinder was just sitting there, right out in the middle of a field. It was a few miles from here. Happened to be just driving by. This end here, it happened to be hooked to a blade of some sort, and this end was hooked to, what good fortune. So going off of the serial number, I was able to find the part number for this cylinder, and Caterpillar says it is a 65 millimeter bore, which I don't know, I'll have to take it apart and see, but it might be a pretty heavy wall tubing. This is awfully heavy, and the length of it, the stroke length was 450 millimeters. So right there should be 450 millimeters. So we'll see if this one's going to work. And that's what our math is going to be on today. To recap our specs, we had 25 gallons a minute at 3000 psi. Now the cylinder had a 65 millimeter diameter bore and a stroke length of 450 millimeters. Now the stroke length really doesn't matter for what we're doing here today, but I just thought I'd write it down. Now normally how I would do this is convert this number into inches and then do my math formula the same way that we did before, and I find it a lot easier just because doing this math in metric to me is tricky, but let's do it in metric. So to start off, I'm going to convert all my imperial stuff into metric. Okay, so gallons a minute, 25 times 25 times 3.78 equals 94 liters per minute. PSI, I know 145 PSI equals 1 megapascal, so let's try that. So we'll go 3000 divided by 145 equals 20.69 MPa. And there is the output of my pump. Now in metric, we've got my cylinder diameter. So now we can figure out how much force that cylinder is going to put out when we put the oil into that end. Going back to our triangle, force, pressure, area. So if we're talking imperial, force is pounds, pressure is pounds per inch squared, and area is inches squared. Just two basic units. They're saying mass and force use the same unit. When we're talking in metric, mass is measured in kilograms, force is measured in newtons. So we're going to have newtons on the top. Our pressure, which in imperial is pounds per square inch. Our pressure in metric is a pascal. And area, this is a weird one, meters squared. So those are my base units for metric. 1 Newton, 1 Pascal, and 1 meter. There's my triangle. So we're trying to find the force, so I cover up the force, and I'm left with pressure times our meters squared is going to give me the amount of newtons. So pressure is in pascals. I know what my pressure is, 20.69 megapascals, big M, so it's like a million. So if I go 20.69 megapascals, if I just put a whole bunch of zeros behind it, if I want to change this from megapascals to Pascal, I just need to move the decimal place 6 places that way. 1, 2, 3, 4, 5, 6. There it is there. 20,690,000 pascals. So I'm not even going to put it in there. So now we need to get our area. The cylinder was 65 millimeters in diameter. Our answer needs to be in meters. So there's a few things we can do. We can figure this out all in millimeters, our area in millimeters, and then divide it by whatever it takes to get it into meters. Or we can convert this into meters right away. And I prefer to convert right into meters rather than trying to convert it after, in that I always seem to miss 1 decimal place for some reason. Not all the time, but quite often I do it. It's a very common mistake to make. Where if I convert this into meters, it works out a little bit better. So 1 meter, if I divided that into 10 equal parts, that is I don't know why I wrote a 6 there. That is a decimeter. If I convert the 1 meter into 100 equal parts, centimeter. And if I do it into 1,000 equal parts, millimeter. So I know these are in thousandths of a meter. So if I want to get it into meters, I just write a whole bunch of zeros and write my number, and then move the decimal place the opposite direction 3 times, because there's 1,000 of them and there's 3 zeros in 1,000. So that equals 0.065 meters. Now I can do my area formula. Actually, I'm running out of room, so I'm going to get rid of some stuff. So area equals 0.7854 times diameter squared. Area equals 0.7854 times 0.065 times 0.065. These are in meters. So meters times meters, we're going to end up in meters squared, which is exactly what we're after. 0.7854 times 0.065 times 0.065 equals this here 0.003318315 meters squared. So now I know my newtons are pascals divided or multiplied by meters squared. So I take that, multiply it by this number, times 20,690,000 equals 68,655 newtons. I have no idea if that's what I needed or not. Another thing that's handy to remember is 1 kilogram equals 9.8 newtons. So if I've got this many newtons, I just divide it by 9.8 and that'll give me my kilograms. So divide that by 9.8 equals 7,005 kilograms. Well, that's sounding a little bit better. If I want to know this in pounds, because our original math, we were looking for somewhere between 14 and 15,000 pounds, I got to multiply that 2.2, because there's 2.2 pounds in every kilogram, 15,412 pounds. So as you can see, doing these calculations in metric it's a little more involved. We have meters squared, and our cylinders are very rarely 3 feet by 3 feet. So they're very, very small numbers when we convert it to meters squared. A Pascal is a very small unit of measure. As you can see, this here, this 20,690,000 pascals is equal to 3,000 psi. So the Pascal number is very, very large. Another thing is using force in newtons. It's a little bit trickier, so we need to remember that there's 9.8 newtons in every kilogram. So a few things to keep track of when you're doing your metric math. Remember the formula, and then we need to remember that area is meters squared, and newtons, we have to convert our kilograms. Often we are talking, I need to be able to lift a load of 20,000 kilograms. We have to convert it to newtons for this to work out, so we can figure out how big the cylinder or how much pressure is going to be in our hydraulic cylinder to lift that load. Another very common mistake. Someone tells us our cylinder is 8 centimeters in diameter. We don't have to convert this to meters right away. We can do it in the small units first. So area equals 0.7854 times 8 times 8. That would equal 0.7854 times 8 times 8 equals 50.27 centimeters squared. Centimeters times centimeters. Now we know we need to get into meters squared. This is where a lot of people run into problems, is getting from centimeters to squared to meters squared. So all I do to remember that is there is 100 centimeters in every meter. So that's 1 meter multiplied by 1 meter, which is another 100 centimeters. I go 100 times 100 equals 10,000. So there's 10,000 centimeters squared in every meter squared. So all I got to do is divide this number by 10,000. See, I almost made the mistake there of only doing 1,000, which equals 0.005027. Looks pretty good. Meters squared. If your cylinder is in millimeters, what we end up with is 0.7854 times 80 times 80, right? Because now it's 80 millimeters. (5,026 millimeters squared. How do I convert that into meters? Super easy. I just need to know how many millimeters are in a meter. There's 100 centimeters in a meter. There is 10 millimeters in every centimeter. So that means there is 1,000 millimeters in 1 meter. So it's 1,000 times 1,000. So that is 1 million. There's 1 million square millimeters in every square meter. So I divide that by 1 million. 0.00502 meters squared. Same number we had before. 3 different ways to get to the same spot. Well, I think that's enough for now. I hope you're getting something out of this and I'm not confusing or making things worse. Let me know in the comments what you think, and thanks for watching.